All right, we're going to look at an example here of using variation of parameters to solve this differential equation. So before we get into the mechanics of solving it, I just want to talk a little bit about why that's the appropriate choice of method, because that will be important when you get to the end of this unit, that you can look at a differential equation and decide which method to use. So we've got a second order linear non-homogeneous differential equation, constant coefficients on the left side. It's very straightforward to find our YH. We know how to do that by finding the zeros of the characteristic polynomial. So we can find our YH very easily. For other problems like this, we used undetermined coefficients where we made a guess and then we found our coefficients A, B, C, D, whatever. That won't work for this one because of the function that we have on the right-hand side of the differential equation here. If you think about the cosecant function and all of its derivatives, the derivative of cosecant is negative cosecant times cotangent. So that's a whole other function. And then the derivative of that, you're going to have to use product rule. So your derivatives are going to start to get more and more complicated, and you're not going to have a finite list of functions that form this function and all of its derivatives. So you cannot use undetermined coefficients for this one. So you're going to have to use something else. So variation of parameters is an option. All right, so we're going to start the same way we started with our undetermined coefficients problems, though. We're going to start by finding our YH. So we would find the zeros of the characteristic polynomial, and just to save space, I'm not going to write that out here, but maybe you can do that in your head now. You'd have r squared plus 9 equals 0. So you get r equals plus or minus 3i. So your YH would be C1 sine of 3t plus C2 cosine of 3t. All right, now when you get into the mechanics of the variation of parameters method, there are a couple of different ways to do that. I prefer to use the system of equations that's in your notes. This is also the way the textbook does the problem. If you look in the textbook, there's also a box with some other equations that you can use. And it's perfectly fine with me if you use those as well. I find that a lot of times students mess up those formulas, though. And so a lot of times students are better off doing the problem the way I'm going to do this, which is setting up that system of equations in the theorem about variation of parameters. So that system of equations says U1, Y1 plus U2, Y2 equals 0. Oh, these should be prime. U1 prime, U2 prime. U1 prime, Y1 plus U2 prime, Y2. So here's my Y1 and Y2 is going to be equal to 0. And then the next equation is the derivative. So U1 prime and then the derivative of Y1, Y1 prime. So derivative of sine of 3t is 3 cosine of 3t. And then plus U2 prime, and then the derivative of cosine 3t is minus 3 sine 3t equals, in that system of equations, it says f of t. So the f of t is your right-hand side of the differential equation. All right, so you're going to be solving this system of equations. And what you want to solve for is U1 and U2, so that your YP will be of the form U1 Y1. I used my Y1 to be sine of 3t plus U2 Y2 cosine 3t. All right, so I'm solving for U1 and U2 to put in here for my YP solution. All right, so I'm going to solve this system of equations. Everyone's a little bit different. It just depends on the kinds of functions that you end up with in your system of equations. So there are a lot of different ways that you might choose to do these problems. I might notice that I can easily solve this first equation for U1 prime and then substitute that into the second equation, or U2 prime and substitute into the second equation. Sometimes these systems are also set up nicely for elimination. So you could perhaps multiply the top equation through by something and the bottom equation through by something and add them together to make some terms drop out. So that is an option as well. I'm going to go ahead and just solve this first equation for U1 prime. So I'm going to subtract U2 prime cosine 3t and divide through by sine 3t. And then I'm going to substitute that into my second equation for u1 prime. So I'll just put the minus sign out front here. So I'll have minus 3 u2 prime cosine 3t over sine 3t, and then times the cosine 3t that's there. This cosecant 3t, I'm going to rewrite that as 1 over sine of 3t, which is what cosecant is, just to help a little bit with maybe the next step in solving this equation. Okay, so again, there's more than one way to go here. I would maybe notice that I have a denominator of sine of 3t here and multiply through by sine of 3t. So when I do that, oops, and I think I lost my minus sign right here. I was expecting a nice simplification to happen, and it wasn't going to happen if I didn't see the minus sign there. All right, so I'm going to multiply through by my denominator, sine of 3t, and that will clear the fractions. So on this first term here, I'll have minus 3 u2 prime cosine squared 3t. And then my next term will be minus 3 u2 prime sine squared 3t. Remember, I'm multiplying through by sine of 3t, all equal to 1. All right, so nice. I have a Pythagorean identity on the left-hand side of the differential equation there, or the equation there, so that makes that a little bit nice. So if I factor out a minus 3 u2 prime, I'm left with cosine squared 3t plus sine squared 3t, which is all just 1. So this whole left side simplifies to minus 3 u2 prime equals 1. And then I can solve for u2 prime. And remember, what I want to solve for really is u2. Here I have u2 prime. And this is a function of t. So in order to find u2, I'm just going to integrate with respect to t. And technically here, I have a plus c. You can neglect the plus c here on your u2. I'll talk about why at the end, but I'm going to need this to plug in for my yp part of my answer here, so I'm going to go ahead and circle that. All right, so there's my u2. I also need my u1, but now since I have my u2 prime, actually, I'm going to go ahead and put that up here and then solve for my u1. All right, so I'm just going to use this that I have right here and my u2 prime. I'm going to put in place of u2 prime. So I'm going to have u1 prime equals negative times negative will be positive 1/3 cosine 3t over sine 3t. All right, which is cotangent of 3t. So if you remember the antiderivative of cotangent, you can leave it like that. Or if you don't remember the antiderivative of cotangent, you can write it as cosine over sine and think through the little u substitution. So if you let u equal the denominator, the derivative of sine of 3t is 3 cosine 3t. So get another extra 1/3. So you'll have a 1/9 out front, the 1/3 that's already here, and another 1/3 from the u substitution. And you'll end up with the integral of 1 over u du, so natural log of absolute value of u. And again, there's a plus c technically here, but you'll be able to neglect that. All right, so the goal here was to find our general solution. I've got my yp part of my solution is u1 times y1 sine of 3t plus u2 times y2 cosine of 3t. So here are my u1 and u2. So it's just a matter of kind of putting those back into this yp and then using that to write my general solution. I'm going to go ahead and just put together my whole general solution here. So y equals c1 sine 3t plus c2 cosine 3t. That's from my yh part of my solution. and then plus the yp part of my solution. One really common mistake here is that students put the wrong part with the wrong function. So that's why it's maybe a good idea to write this down so that when you get to the end, you remember which function here from my u's goes with which function here in my yp. So u1, that's what I have here, 1/9 natural log of absolute value of sine 3t. I'm going to leave off that sign of absolute value of 3t. I'm going to leave off my plus c and talk about y in a second. And then all of that is times sine 3t. So maybe I'll put that sine 3t out front here. And then plus u2, which was negative 1/3 t times cosine 3t. And I don't really need the parentheses there, but maybe it's helpful to remember that that's multiplication. And again, I said to remember that you can neglect the 2 plus c's here. Just notice that if I had a minus 1/3 t here plus c, I would end up with another term of c cosine 3t, which is already accounted for here. So the actual plus c's that would be here could be absorbed into your c1 and c2 as part of your general solution. All right, so there is our general solution. And sometimes, you know, you end up with some terms that simplify, and you can maybe simplify that a little bit. I believe one of the ones in your My Math Lab homework simplifies very nicely in the results. So go ahead and try some of these. There's no step in here that's hard. It's just maybe a matter of getting used to kind of how these problems work and practicing a little bit. So try some homework.